Yesterday, you had some doubts and doubts in the following topic. The topic are, yes, nilpotent matrix we have discussed. Okay, algebraic multiplicity, geometric multiplicity done. Nilpotent, if all eigenvalue zero type of problem, diagonalizable is okay. One is linear transformation to matrix. Linear transformation to matrix. So there was some question uh, linear transformations. What is linear transformations? Answer. If there is a matrix is given and how to find out the problem. See, if you if anybody can who has asked this question, if you can speak, what is the exact question? Okay,
Yes,
if
sir. I can speak. Wait, let me give you the exact question.
yes,
I've written there. Just just a minute. Huh? Yeah. So we have a matrix actually. 0 AB
0 AB
and minus A 0C
0C,
and minus B minus C 0
okay,
and T such that R cube to R cube is a linear transformation, and this is its matrix representation with respect to standard basis R.
okay,
Okay, sir. And then actually I have only one problem in this. This is saying that this does not map any line through the origin onto itself. The line meaning I didn't understand, so that's what I want to ask.
so the question was the this map,
Does not map. This does not map any line through.
समझ गया मैं, this transformation
Hmm.
does not map any line through origin
Or any line through origin onto itself.
onto itself. Okay, okay. So, student, first of all, if you have any problem of linear transformation and you are saying okay, this linear transformation is this one r cube to r cube and matrix is given this one. So first of all, you have to understand whenever you say there is a linear transformation from r cube to r cube, then t of something, okay, t of x equal to like some transformation. Basically, T is nothing but a matrix. Okay, you are saying A is a matrix or you are saying T is a matrix. है ना? So this is A or T that is immaterial. Basically, T of x equal to AX. T is equal to A. Like equivalent. Okay, equivalently we can say, because when you multiply, you will get the same things when you have a linear transformations. So if linear transformation is given, you can find out the matrix by the help of standard basis. And if you have matrix, then you can find a linear transformation by the help of T equal to AX. Okay, just so Tx equal to Ax. So how to find out matrix? How to find out the linear transformation? T of x. X matlab you will write down like here x1, x2, x3 ना, because matrix में इस type से तो multiply करते हैं like that. 0 AB and minus A 0 C. That is AY plus BZ minus AX plus CZ minus BX minus CY. So is it clear what is linear transformation? Linear transformation is clear, I think. Now the main problem is uh, this linear transformation does not map a line passing through origin, a line passing through origin to onto itself. मतलब एक लाइन को लाइन में मैप नहीं करता है. Line passing through origin, what is the meaning of line passing through origin? So you should No, this is very simple problem. Just घुमा के दिए है ना. Problem is simple. First of all, linear transmission is clear. What is the equation of line? What is the equation of line? Because this is you are in 3D. You are in 3D. 3D. What is the equation of line?
So we have to write the equation of plane, sir.
No, no, equation of line. Not saying
Line.
plane. Line equation is x minus x1 upon L,
Yeah,
y
yeah. Okay.
minus y1 upon m,
M
z minus z1 upon n, where
and
lmn
LMNR direction cosine.
डायरेक्शन कोसाइन. और अगर आप तुम लिखना चाहते हो ना एबीसी भी लिख सकते थे, दैट इज डी
हाँ.
आर्स डायरेक्शन रेशियो. देयर इज नो प्रॉब्लम, यू नो ऑल दिस थिंग्स. व्हाट इज डायरेक्शन कोसाइन, व्हाट इज डायरेक्शन रेशियो. एल इज इक्वल टू, आई थिंक, व्हाट इज एल, cos अल्फा. नहीं,
Uh,
डायरेक्शन
I
कोसाइन.
forget actually.
L is equal to cos alpha, m is equal to cos beta, n is equal to cos gamma. Direction cosine, basically the line which makes the angle from x-axis is alpha, which makes from the y-axis beta, which makes from the z-axis gamma, and the cosine is called the direction cosine. Okay, done. Okay, this kind of things you know basically. So if you see this is the equation of a line, then what you are asking, you are saying the equation line passing through a region. So equation will be like equation of line will be x upon L equal to y upon, so y upon m equal to z upon n, and you can take that is equal to k. K is any real number. Okay, so what you are doing, you are saying the point which is on line. What is the point? The point is x equal to kl, y is equal to km, and z is equal to km. Okay, so what is this? This is a point on a line. This is general point. This is generalizations of kl, km, km. Okay, this is the generalizations. So what do you have to prove that if this is a point, then right hand side when you have a mapping, you have a mapping. The mapping, this point map to a line. Let us consider. Okay, if this map, this is linear transformation which is mapping to a line, then this is not exactly that line whatever we have done. Okay, we have to prove. Yeah, we have to prove. So you have the transformation like ax plus ay plus bz. So what we can say, kl, km, km, xyz, kl, kl, km, km. ठीक है. Sorry, ay plus bz minus ax plus cz minus bx minus cy. ठीक है. ओके, पुट दिस kx, मैंने अभी ये रख दिया. दिस इज, यू कैन नॉट. AY. Now can you do this thing? This you can multiply all these things. A of y. Y is Km plus B of Kn. Okay. Minus AX. Minus A of X. What is X? X is KL plus C of Z. Z of K. Minus B of X. X मतलब KL. Minus C of K. ठीक है? Is it clear? So tell me one thing. You can take common K. There is no problem. But is it a format of Km, KL, Kn? That is AM plus Bn. K times of minus AL plus Cn. ठीक है? अब बताइए मुझे. Yes.
No, it is not of that type, but what should we
That is not of the type, because KL type, we need KL type. Okay. KL mapping to like something, not, I am not saying that is a, okay, K times of L. L is the direction ratio. So this is not the direction ratio of that line. So this is not mapping to a line into line. Whatever line you are saying. Is it clear?
Actually, sir, I was not able to understand what question is saying.
Now it is clear.
So I've just known that a question is now जैसे कि आपने समझाया उससे पता चला कि क्वेश्चन ये कह रहा है कि ये ट्रांसफॉर्मेशन किसी ऐसी लाइन से मैप नहीं होता है
नहीं
जो
Question is saying, let us consider, see, let us consider you have a function. क्या ये फंक्शन लाइन को लाइन मैप करता है?
हाँ सर, ये तो मैप करता है.
देखो, ये लाइन बेसिकली ये हमारे पास एक y इक्वल टू fx थी एक लाइन. हाँ, हमने डेटा लिया x, y इक्वल टू x, तो लाइन को लाइन में मैप कर दिया. ओके, इफ यू टेक a circle, not circle, if you take a parabola, y इक्वल टू x स्क्वायर, y इक्वल टू x स्क्वायर डेटा डालोगे, x स्क्वायर टाइप में डेटा डालोगे, can this map to them map? Basically this is called like a transformation which maps something to something. Basically you have a mapping. That mapping, if you take 2 dimension, 3 dimension, if you take 4 dimension, then whatever figure on the left hand side in the domain, is it mapping to right hand side? So this kind of problem is there. Okay. You can understand.
onto itself का क्या मतलब है सर? मतलब
onto अपने आप में मैप नहीं करता है. Basically we have a transformations. Okay, we have a transformation which map itself. Let us consider you have a mapping like x, y, z. Okay, I am saying this is if you take ठीक है, x, y, z. X, y, z. So if you have a line, this is a line. Okay, whatever line in 3D. Okay, no, not this is the pain point. There is some line. Let us consider this line is passing through this. So this will map the image of this line, whatever point on this line, this point, if you take mapping and collect set of all points which are mapping to this line, that will be this line, same line into line. Okay, see, line into line. Okay, am I clear? हो सकता है कि लाइन, ये वाली लाइन यहां पर मैप हो जाए, ये वाली लाइन ऐसे मैप हो जाए, लाइन इनटू लाइन. ओके, बट ये कह रहा है कि लाइन इनटू लाइन मैप होती ही नहीं. Am I clear?
Okay.
लाइन इंटू लाइन मैप होती ही नहीं है. Yes. So this kind of transformation. तो मतलब लेफ्ट हैंड साइड line points on the line that will map onto the right hand side, which is the same line. Onto मतलब the same line. The same line, all the points will be same. If all the points will be same, the line must be same. It means
Same
image
kind
is
of.
also like a codomain.
Yes, sir. I've got it.
Yes, simple. This
समझ
is
में आ
very
गया.
simple.
हम्म.
You can understand this point by taking this example. If I'm
Yes, yes,
asking
sir.
you p of r square to r square is very simple. Take some ठीक है, this line. Okay, so basically this is r square is here, this is r square is here. I am saying just go after the class, just check and tell me sir क्या ये आंसर कुछ आ रहा है. This is a linear transmission. ये लाइन, इस लाइन को जो ओरिजिन से पास होती है, ओरिजिन से पास होने वाली इसी लाइन में मैप करता है. या फिर हो सकता है, मैंने कहा चलो एक लाइन है जो 30 डिग्री पर है मान लेते हैं,
हाँ.
ठीक है, या फिर 45 डिग्री पर ले लेते हैं. मैं तुम्हें समझा
Oh.
देता हूँ, तुमने क्वेश्चन
Yes,
पूछ
yes.
लो.
Y equal to X type line.
y is equal to x टाइप में. ओके, जस्ट 1 मिनट. So student, what I am saying ki you have this angle, let us say this angle is 45 degree. So this just okay, just check this problem. What is this? What is this point? Y is equal to x line. So y is equal to x line. What is t of x comma x? That is 2x comma 0. So what is 2x comma 0? Here what is 2x comma 0 type point? What is 2x
Yeah.
comma 0?
Another line type, sir.
No, what is this 2x? Is it y is equal to x?
It is Y equal to 2X line. Na?
How can you say 2x comma 0?
2X comma 0.
What is
Okay.
2x comma
Yes.
0? If you take
Okay.
x,
It's axis. It's axis, I think.
because x is a real number, whatever this will be mapping, what this is mapping. See, this line is going to, this line is this one, this is mapping to this. So we have this
It's looking
transformation
like
has
no
rotate.
ordered pair, sir.
No, this is we had this line y is equal to x and y is equal to x. This is a transformation, and you can say this is a rotation transformation. Why? Because this line has been rotated to this one. Am I clear? मेरी
Yes,
बात
sir.
समझ में आ गई? Because 2x comma 0 means left hand side you will give x equal to 1, here 2 x is a real number, then 2x is also real number. X is mapping to 2x and y is mapping to 0, y 0 only x axis. It means this line is rotate to x axis. Okay, but our question was कि this line will not rotate to x axis. Whatever this line is, this line will be same as this. So this is called a fixed point theory. मेरी बात समझ रहे हो? फिक्स पॉइंट थ्योरी, फिक्स पॉइंट तो एक होता है, पर इस लाइन के अंदर इनफाइनेटली मेनी फिक्स पॉइंट है. ओके, मतलब जो पॉइंट था ना, इस ट्रांसफॉर्मेशन ने चेंज नहीं करा. इज इट क्लियर? मेरी
Okay,
बात
sir.
समझ रहे हो? अगर मैं और डीप में जाऊंगा, what is the meaning of fixed point? There are so many infinitely many fixed point. This is a vector which is fixed point. The meaning is this can be the eigen vector. मैं थोड़ा और डीप में नहीं जा रहा, otherwise this class will be ending. और ठीक है, ये क्लास इसमें
Okay,
निकल
sir.
जाएगी. आइगन वेक्टर क्या होता था? आइगन वेक्टर में भी यही करते थे, ax इक्वल टू लैम्डा x. अगर लैम्डा कोई अगर वन आइगन वैल्यू आ गई तो ये ट्रांसफॉर्मेशन, दिस मैट्रिक्स is converting this whatever this or coordinate system is there on the left hand side, this is column matrix, into this same to same. What is same to same? Am I clear? You have some like clear cut idea ki what is this problem? Okay, I can discuss this problem, I can give you some more problem, and I can complete the time 2 hours. Okay, but my problem will not complete.
Yeah,
So
sir.
I am not going to discuss.
I'll play the video again and again later, na?
Okay, now this problem is I think very much clear ki what the question is saying and what we
Yes,
want.
yes.
Okay,
Mm.
yes, no, so your problem is clear. So whenever you have some problem related to linear transformation, let us consider we have one problem like I think there is, if somebody is saying 1 2 0 2. Okay, this is a matrix 2 cross 2. And somebody is saying 1 1 2 1. Okay, this is also 2 cross 2 matrix. This is A, this is B. Somebody is interested to find out the null space of this. Find the null space of A. Do you know what is the meaning of null space? Can you find out? And somebody is asking how to find out the range space of B. How to find out? Basically, if somebody is saying range space, null space, then it is better. Null space is very easy. See, null space is very easy to find out. Yes or no? Because null space means Ax equal to 0. Set of all values of x such that Ax equal to 0 is called the set of that is called the null space. Yes or no? Is it clear? Null space Ax equal to 0. How to find out null space? Tell me. What is the null space?
Sir, we can find basis for null space, no? Are you talking about
Yes,
basis of null space?
Yes, you can find out. So null space is Ax equal to 0, na?
Yes, ax equal to 0 put करेंगे and we'll find the value of xy,
So
x1,
x
x2
y
जो
is
भी
0 0 because this is only the null space. Yes,
हाँ.
Manoj is saying, yeah, this you can find out the answer. But basically, if somebody is saying ki find out the null space and problem is like a complicated problem, so sometime if I don't know what kind of problem will IIT exam will ask, but in this problem also we can convert into matrix to linear transmission also. This is a linear transmission from R2 to R2. So whenever you feel some difficulty, you can convert matrix to linear transmission. And if you feel some difficulty to the linear transmission, you can convert into the matrix also. So you can say, sir, this is x plus 2y and this is 2y. Yes or no? This is a linear transmission. Is it clear or not? If somebody is asking what kind of dimension, fala, any kind of problem, because null space in matrix, maybe sometime you feel some difficulty. Like if matrix we have, but somebody is asking the eigen values of linear transmission. Somebody is asking eigen value of linear transmission. So what you will do? So थोड़ा सा हमें लगता है यार eigen value how to find out. So directly, what you can do, you can convert the matrix, the linear transmission into the matrix, and matrix eigenvalue, whatever matrix eigenvalue is there, then you can say this is the eigenvalue, eigenvector, whatever they will ask. Okay, they will ask nilpotent linear transmission, nilpotent linear transmissions. You know, nilpotent linear transmission. We have done a lot of problems on the nilpotency linear transmissions also. Okay, so null space is given, but whenever somebody is asking range space of this, so how to find out by the help of matrix? मुझे तो थोड़ा difficult लगता है. So what I will do?
इसको कॉलम स्पेस भी बोलते हैं ना, रेंज स्पेस के बेसिस को फाइंड करने को.
See, range space जो है, आपसे कॉलम स्पेस, सी जो कॉलम स्पेस है, कॉलम स्पेस निकालते हो और कॉलम, यस, कॉलम के लीनियर कॉम्बिनेशन से बनाते हो, दैट इज कॉलम स्पेस.
यस, एंड दैट इज सेम एज द वही सर, रेंज स्पेस का भी बेसिस हम उसी से ही फाइंड कर सकते हैं ना, कॉलम स्पेस निकाल करके. सेम लाइक ऐसा मैंने कंसेप्ट देखा था एक जगह.
मैं इतनी टेंशन नहीं लेता, मैं कहता हूँ x plus 2y 2x plus y. ओके
ओके
ओके, what we will do, t1 comma 0, that is 1 comma 2, and t comma 2 comma 0 comma 1. This is the standard technique. मैं एग्जाम में जाकर कंफ्यूज नहीं होना चाहता. So this will generate the this t12 t11. What is this? This will generate the whole range space. This is Li or not? 1 2 1 1. This is Li.
Yes,
this is Li. This is Li. This is a basis. Do you know these things?
Yes sir. This is basis, right?
This is basis.
Like
this is very simple. So why you enter in a difficult things? Yeah, this is a column space. Fala. We know this technique. We can convert a matrix into the. Whenever you find null space, it is very easy of a matrix. But whenever you find a range space of a matrix, this is somehow difficult. You have to think. Why will you think? Don't think. You convert it to the linear transform and tell me what is the answer.
Yes, sir. Because sometimes it also asks the dimension of nullity of a intersection range of a.
Yes, this is the question. So let us consider. this kind of problem you have. So what is this and this intersection? Where? What is this and this intersection? Basically, this and this intersection only 0, 0. So
0, 0,
dimension of
yes.
null space and range
Intersection.
space.
Intersection, yes.
Dimension of null space, intersection, range space. So B matrix is only 0, 0, 0. So that is dimension is 0. Is it
Yes.
clear?
Yes, sir. Perfectly clear.
Can you give me the question? Which question you are asking? Dimension of
Okay. Okay,
nullity
sir.
and this.
Write it. A equal to
A equal to
1, 2, 0
1, 2, 0.
and minus 1, 5, 2, and
Yes.
that is it. And B equal to 1, 2, minus 1, 0 and 3, 1.
So student, this is the question 2 cross 3.
Nullity of A intersection range space of B. That is, we have to find the dimension of this thing.
This one.
Yes, sir.
So student, have you done this problem? Anybody has done this problem? Anybody has done this problem? Yes or no? फटाफट बताइए. किसी ने करी है? So this is the problem which you can simply see. Dimension of, see, dimension is, you cannot say this is the dimension of NA intersection dimension of RB. Can you say like this? This is wrong, na? Dimension. How can you say dimension? These are the real number. Dimension of the integers, positive integers, intersection of positive integers. What is? So basically, what you have to do, you have to find out the set. What is this set? What is this two spaces? So whenever you have two spaces, then you have to find out the intersection of two spaces and find out the answer. Okay. Am
Yes,
I
sir.
clear?
Yes, sir. To find nullity of A, we have to multiply it by like x1, x2, x3, and then we have to find those values, right, sir?
Yes, yes. So I am going to do. Just
Yes.
keep silence. Wait for 1 minute.
Okay.
Okay. The 1, 2, 0 minus 1, 5, 2. So basically, how to find out nullity? Nullity we are going to find out 1, 2, 0 minus 1, 5, 2. A minus 1, 1, 2, 0, 0. Solution ही तो निकालने हैं. Solution does not affect ना. Do you know nullity इसकी निकालने same thing है, because you are going to find out x equal to 0 ना. Solution निकालने ना. Solution is called nullity. Solution of
Yes, sir.
equivalent
Yes,
matrices
sir.
are same.
Yes, sir.
So what I'm saying, this equation is x plus 2y is 0, and this is 7, y plus 2z is 0. So you can put one variable as free variable. So can we take z equal to, so I am going to take x equal to free variable, that is k. If x equal to k, then y is equal to minus k by 2. है ना? So 7 into y मतलब minus k by 2 plus twice z equal to 0. So twice z equal to minus 7k by 2. So z is equal to minus 7k by 4. So you have the nullity x, y, z, that is k times of 1 minus half minus 7 by 4. So you can convert into the integral entries like k times of 4 से multiply कर देते हैं तो 4 minus 4 कर लेते हैं, minus 4 से multiply in all these things. So you will say that is 1, that is 7. Do you know this thing? Is it okay?
2 or 7, sir. Minus 4, 2, 7.
Okay. If you multiply by 4, this will be 2, 2, 7. So basically, this is one of the linearly independent solutions. Okay. So this is done. So what I am going to do, this problem x, y, z, which is equal to k times of minus 1 to 7. You can say null space of A is set of all k's minus 1 to 7. K belongs to all. अच्छा किसी को doubt तो नहीं है why this is here? Why k you have multiplied by 4? Because we have made the perfect integers, perfect number. Okay. In the same way, when you want to find out the like range of B, so range of B is very difficult how to find out. I am doing the same thing. I am going to convert into the matrix into the linear transformations. So minus 1 2. Okay, this is problem done. And like b equal to minus 1 2 1 2 minus 1 0. देखो यही प्रॉब्लम है. दिस इज द प्रॉब्लम. 1 2 minus 1 0 1 2 minus 1 0 3 1. Yes, 3 1. So what is the linear transformation t x y z? X minus y plus 3z and 2x plus z. So you want to find the linear transformation 1 0 0, that is 1 0 0. What is this? 1 minus 0 1 2x 2x है ना, this is 2x 2. Okay, t 0 1 0. What is this? 2 1 0 0 3 0 0 0 3 1 0 0 0 1 0 0 1 0 to minus 1 0 1 0.
Sir, can you tell me how do we get a txyz equal to this thing?
Multiply this one. Already we have discussed now.
Sir, how can we multiply it by 3 like vectors? We can have only 2, na?
Is there any mistake? Why?
Yes sir, I think we can take only xy only, na?
Why? अच्छा, इस मैट्रिक्स में मल्टीप्लाई कैसे करोगे?
Because
2 cross 3 मैट्रिक्स.
sir,
wait.
this is 3 cross 2 matrix and we have
sorry. I have done a mistake. I was thinking, okay, this is 3 row and 2
a
columns.
little mistake,
We'll
sir.
multiply xy. Sorry.
Yes.
We'll multiply xy.
Yes.
What? कुछ गलती कर दी है. T of x y, this is x plus 2y minus x or 3x plus y. So this thing you have to understand है ना, कभी कभी गलती हो जाती है इस टाइप की.
It's okay sir.
So this is मतलब not, मतलब आप ना कर पाओ, मैं तो कर दी गलती, पर एग्जाम में आप ना कर पाओ. X is 1, that is minus 1, that is 3, and that is t of 0 comma 1. This is 2 and 0, and that is 1. Okay, so these two vector I think linear independent or dependent? मुझे तो linear independent दिख रहे हैं.
Independent they are. They are independent sir.
They are independent. These are alike. So you can say I can say null space of A, which is equal to, we have done, this is minus 1 2 7 and range space of B, that is a linear combination of minus 1 minus 1 3 1 minus 1 3 and 2 1 2 0 1. Yes. So now can you tell me what are the common vectors? मेरी बात समझ रहे हो? उससे जनरेट हो रहे हैं Na के अंदर इनफाइनाइटली मेनी वेक्टर्स. NB के अंदर इनफाइनाइटली मेनी वेक्टर्स. So what is the answer?
May I tell you answer sir?
Yes.
I'm not solved yet, but I know the answer actually.
What is the answer?
Answer is 1.
How it is 1?
That's why I don't know sir.
How this is 1?
Actually it can be written as the linear combination of nullity element. The range space can be written as,
yes, so you can write down that is K1 and K2. Okay, this is, you can write down like this. See, इन दोनों का intersection लेना है. Intersection. How to find the intersection? Number 1. Tanu saying, sir, this is not possible. Okay, so अच्छा, मुझे एक चीज बताओ, बस मेरा एक क्वेश्चन, -127 1 -1 3 2 0 1, इसका डिटरमिनेंट निकालना, डिटरमिनेंट क्या है, डिटरमिनेंट फाइंड आउट।
सर कैन यू कंफर्म दैट इट इज 201? एक बार पीछे देख लें, मेरे को लाइक थोड़ा सा लग रहा है यहाँ शायद 201 ना हो। एक बार देख लीजिए 201।
If your entry is okay, 1 + 2y - x 3x + y 1, 0, that is 1 -1, and 3 0 1, that is 2, that is 0, that is y is 1.
Yes sir,
Then
it's
minus.
going good because I have also calculated na, so I was not able to get that.
So find the determinant of this.
Okay.
What is the determinant of this? Determinant निकाला तो इस मैट्रिक्स का जो मैं निकाला है determinant, determinant is 11. What is the determinant of this? No.
Wait sir, let me find. See, I will check why the answer is minus, why you are saying that dimension is 1. As see, देखो basically if this is a problem, I can say the answer is only 0. See, this vector, देखो ये दोनों वेक्टर तो आपस में li है, linearly independent, you know, and if I include this vector also, then this is also li. If these three vector are li, then one cannot be written as a linear combination of other. Yes or no? If मान लिया ये दोनों का li है, ये इसके linear combination में नहीं लिखा जा सकता. It means the null space of any element cannot be written as a linear combination of this. If this cannot be written as a linear combination of this, then what you can say? If these two are linearly independent. Independent means you cannot find any intersection except 0. So we will have only intersection as 0. Then answer must be 0. Then answer must be 0. The dimension of a null space is also. Dimension of a 0 space is always 0. So in according whatever question you have, I don't know what is the mistake either we have done or like some like error in the question. No sir, you are right sir, you are right. बट लेकिन लास्ट में ना मेरे पास सॉल्यूशन भी है इसका ही, पर लेकिन उसमें लास्ट में रेंज स्पेस आप की तरह सेम टू सेम निकाला है, पर लास्ट में उसने लिख रखा सच दैट -a + 2b = 0. लाइक आपने k लिया है ना, तो k1 k2 लिया ना आपने, तो उसने a और b लिया है, तो सच दैट के बाद k1 k2 बिलोंग्स टू r की जगह उसने लिख रखा है -a and + 2b = 0. then it is the range space, else it is not.
एक मिनट रुको, थानु यू आर सेइंग k कैन बी टेकन एज 0. यस, सी सिंपल, मेरी बात सुनिए. range space has these two vectors. Range space is generated by this, so range space can be done as a linear combination of this. So range space has two linearly independent vector. Okay, and third is this is called a null space. Okay, this vector is there. Okay, 0 is always there because this is null space. 0 is always present there. Okay, because k is a real number na. Except 0, any vector, this vector is linearly independent to this. These two are linearly independent, and if you include this vector also, this is also li. This is also li. It means no vector, single vector linear independent is a linear combination, is a linear multiple of any vector of this or sum of this. Otherwise, these three will be LD. अगर ये 0 आ जाता, it means the dimension of this is 1 because intersection has only 1 or 0. So 0 cannot be, answer is 1. Okay. Okay, I will check. I will think also ki why somebody has written answer as 1. Okay, but in according to me, क्या कह रहे थे भाई, a plus 2b क्या लिख रखा है?
सर आपने K1 एंड K2 लिया ना, उसने बस a+2b a और b ले रखा है उसकी जगह पर, एंड द सेम उसने रेंज स्पेस भी सेम आप ही की तरह निकाला है, एंड बट सच दैट करके उसने आपने लिख रखा है K1 K2 बिलोंग टू R, बस उसकी जगह उसने लिख रखा है -a+2b इक्वल टू 0।
-a+2b 0।
बस ये समझ में नहीं आ रहा ये स्टेटमेंट आई कहाँ से।
कुछ प्रॉब्लम कुछ और भी हो सकती है। देखो माइनस, पहली बात तो इस कंडीशंस पर, इन दोनों कंडीशन पर -a+2b 0 कैसे लिखा है? वेट पीछे,
मैंने पूरा क्वेश्चन आपको बता दिया सर, वैसे तो इसके अलावा और कोई कंडीशन नहीं है।
यू
2016
आर
का
आस्किंग, क्वेश्चन कहाँ आया है?
2016 में आया सर, जैम में।
इसने दिया है A is this one. Nullity is one. Okay, we want. Okay, in this book, this is not clear. क्या इसने लिखा होगा, इसका कोई क्लियर नहीं है। Okay, I will check and let you know. ठीक है। Why -a+2b is written? There is no logic. ठीक है। Basically, in my book, what they are saying? They are saying, okay, this is nullity is 1. Okay, nullity is 1, and this is rank is, because range space is rank, so rank is here. What is the rank of here? Rank is 2. So what is any intersection and RB, है ना? Any intersection RB they are asking. Okay, they are asking any intersection RB. So they are saying W1 plus W2 is equal to W1 plus W2 वाली problem होती है ना? They are saying like this: dimension of this, dimension of this, dimension of this, dimension of this. They are saying this is 1, this is 2, minus whatever the problem. They are saying that W1 plus W2 is this one. But W1 plus W2, how they have written this one? They have fitted the answer. I don't know the solution book. Whenever you see some solution book, they fitted the answer. Basically, answer is given in IIT. Let us consider there is some answer key, and they fit the answer in solution. फिट कर दिया ना, तो सॉल्यूशन बुक छप गई हमारी, कैसे भी छाप दी, बस बुक बन गई, वो सॉल्यूशन हो गया फॉर द टाइम बिंग। तो वो बना दिया है, मुझे ये समझ में नहीं आया उसने बिना सोल्व करे कैसे लिख दिया इसका आंसर जो होगा, एक्सप्लेन नहीं कराया उसने, है ना। सो वी विल डिस्कस, वी विल टेक this problem and discuss later on कि why the answer is, you are saying the answer is 1. I will check and let you know.
यस सर, मैंने अभी ऑफिशियल वेबसाइट पे भी चेक कर लिया इसको, तो उस पर भी आंसर की है ना, तो उसमें 1 दे रखा है आंसर।
हो सकता है, पता नहीं क्या दिया है, आई हैव टू। अच्छा, कोई बताएगा ये आंसर 1 है सही में? कोई ऐसा स्टूडेंट जिसे ये समझ में आया है कि जो हमने निकाला है, क्या हमने कुछ गलती करी है? किसी को लगता है कि आंसर 0 है, सॉरी आंसर 1 है इसका? यस। If we use that formula, it is 1, otherwise 0. ऐसा होता है थानू कभी कि अगर हम एक फॉर्मूले से यूज करते हैं तो आंसर इज 1 अदरवाइज 0? दिस इज नॉट पॉसिबल। सो व्हाई दिस इज 1? हाउ? अच्छा, आई डोंट थिंक इट इज रॉन्ग। सी, टेल मी वन थिंग, व्हेन यू फाइंड आउट null space intersection this, you have two space, and tell me one thing कि what is the dimension of W1 plus W2? See, I want to tell you one thing. पता है, I want to tell you one thing. मैं अपने आंसर पे थोड़ा सा अड़िग हूँ कि गलत क्यों हुआ। ऐसा नहीं है, टाइम वेस्ट नहीं हो रहा है, इससे हमें चीजें सीखने को मिलेंगी। कभी भी W1 प्लस W2, मैंने एक बार बताया था आपको, W1
यस
प्लस
सर।
W2 इज, बुक में भी पढ़ा होगा तुमने, दैट इज L ऑफ
हाँ
W1 यूनियन W2, पढ़ा है कभी?
हाँ सर, आपने बताया था वैसे बुक
बताया
में
भी
तो।
था। दिस इज ओके, यू कैन से कि वॉट एवर W1 W2, so W1 plus W2 is generated by W1 union W2, so it means basis of this, and इसकी बेसिस आपस में लीनियरली इंडिपेंडेंट है। तो W1 प्लस W2 की डायमेंशन तो 3 आ गई, 2 कैसे आ गई? मुझे ये भी नहीं समझ में आ रहा। मेरी बात समझ में आ रही है नहीं आ रही है?
यस सर।
इसकी और इसके तीनों की डायमेंशन 3 नहीं आ गई, 3, because W1 plus W2 is generated by W1 union W2. I can prove right now also, and I have a book also. In each and every book this is written that W1 plus W2 is generated by W1 union W2. So W1 plus W2 generated by these 3 vector. अगर इसमें से जो LD वेक्टर है उसे हटा दो, या तो हमने कोई मिस्टेक करी है इस कैलकुलेशंस में। इफ देयर इज सम मिस्टेक, सो आई कैन एक्सेप्ट या मिस्टेक इज देयर, अदरवाइज द आंसर इज ओके। डन। चलिए हम इतना डिस्कस नहीं कर रहे हैं, गोइंग फॉरवर्ड। Now, what are the different problems?
मुझे सर एक जगह पता है क्या लग रहा है कि अगर हम लोग उसमें मल्टीप्लाई वगैरह वो जहाँ पर किया था नलिटी,
कुछ गलत हो तो बताओ। I don't know, एक मिनट पीछे आ जाते हैं।
नलिटी में लाइक 4 से ना मल्टीप्लाई करके अगर ये रहने तो क्या पता शायद ये
उससे कुछ नहीं होगा,
नहीं होगा। नहीं होगा सही
उससे
बात।
कुछ हो जाता तो हम कर ना देते। इससे -1 2 0 -5 2 कुछ R R1 माइनस 0 0 x plus 2y 7y plus 2z x equal to k, x equal to k रखते y is equal to minus k by 2, y is equal to minus 7 2z is equal to minus 7 k by 4, k minus 1 by 2, 4 से मल्टीप्लाई करी दैट इज -4 से -4 2 -2 7। अरे यार कुछ गलती नहीं करी यहाँ पर, ये -4 था, दिस इज -4, ठीक, -4 2 7, यहाँ पे लिख दिया हमने -1।
वो
ये तो कह रहा हूँ हो क्या रहा है
यस
-4।
यस यस सर। अब वो लिनियरली डिपेंडेंट हो जाएगा सर, सही बात है।
मैं इतना डाउट, मतलब गलती हुई तो हुई कहाँ पर, यस एक बार चेक करना जरा सा। सानू यू आर सेइंग कि उस फॉर्मूले से आंसर आ जाएगा, इससे नहीं आएगा, ऐसा नहीं होता है ना। नहीं नहीं बेटा, इसमें हंसने वाली बात नहीं है। बेसिकली वो कैरी उससे आंसर आ सकता है, बट मैं आपको बता दूं ऐसा कभी नहीं होता है। अगर आपके कॉन्सेप्ट, इफ योर कॉन्सेप्ट इज क्लियर, ओके, तो वो आंसर सेम नहीं आ सकता, नो, अदरवाइज वो थ्योरी फेल हो जाएगी, है ना। इट मींस इफ देयर आर समथिंग व्हिच इज लाइक प्रॉब्लमेटिक, तो आंसर वहां से गलत आ सकता है ना। देखना जरा, वंस यू चेक, व्हाट इज द डिटरमिनेंट, 0 आया नहीं आया, अब भी नहीं आया। अभी भी 0 नहीं आ रहा, सो वी विल चेक। यस प्रांशु, यस यू कैन स्पीक।
हेलो।
यस यस।
सर मैंने जो नलिटी निकाली है वो बैक सब्स्टिट्यूशन से निकाली है, तो मेरी नलिटी आ रही है 4k इंटू 4 - 2 इंटू 4 - 2 और 7, तो उससे डिटरमिनेंट 0 आ गया सर।
4
-2 और 7।
-2 और 7।
बैक सब्स्टिट्यूशन, जेड को के माना फिर नीचे से सॉल्व किया फिर उल्टा।
तो फर्क तो उसमें
Back-
पड़ना चाहिए। यू आर सेइंग 4 - 2 7 रखा तुमने, 4 - 2 7, ये तो गलत हो जाएगा हमारे हिसाब से। तो 4 - 2 -7 आना चाहिए। पीछे आओ जरा। प्रॉब्लम दिस वन -1 2 0 -1 5 2। क्या ऐसे कन्वर्ट करा, ये मैट्रिक्स कन्वर्ट करी?
yes sir।
ठीक है। उसके बाद
7y plus 2k is equals to 0।
7y + 2k = 0। तो y
y
is
equals to minus
-2 7। then
and
z
then minus
x = -2y माइनस x = -2y, तो 4/7 आ गया। यही आ गया। x = -2y है। तो बताओ क्या आ गया? x =
सर
4।
7/4 शायद सर पॉजिटिव होगा, एक बार चेक कीजिए तो।
कहाँ पर?
7/4 जो हमने लिया है ना, शायद वो पॉजिटिव आएगा, नेगेटिव नहीं आना चाहिए। इफ वी टेक x एज k।
x अच्छा, यहाँ पर कुछ गलती करी है।
हाँ सर, वो 7/4 पॉजिटिव आएगा। x if we take k, y is equal to
हाँ,
-k/2 and if minus
कोई
minus
चेक
got
ही नहीं
plus,
कर रहा है। यस, कोई चेक ही नहीं कर रहा है
7
कि सर गलती कर दी आपने कैलकुलेशन।
7k/4।
इतना हम सोच रहे हैं कि हमने गलत निकाल दिया, हमारी कैलकुलेशन ही गलत है, हैं?
Doing silly
कोई चेक
mistakes
नहीं कर
sir।
रहा है। 7/4। ग्रेट, यू आर गोइंग इन द राइट डायरेक्शन। मतलब मैंने गलती कर दी तो गलती पकड़ी नहीं गई, तुम पे गलती क्यों कर रहे हो सर? है ना? बहुत बढ़िया। अब समझ में आ गई बात। चलो,
अब 0 है सर ये।
ये काम तो खत्म हुआ। कम से कम इतनी सारी प्रॉब्लम देखने के बाद ये समझ में आ गया कि छोटी छोटी गलती से हम LILD गलत कर सकते हैं, एंड वी कैन डू ब्लंडर इन अवर पेपर। सो दीज थ्री आर लीनियरली डिपेंडेंट। मतलब ये दोनों इंडिपेंडेंट थे, ये इससे डिपेंडेंट है। मतलब इससे ये बन सकता है या इससे ये बन सकता है। यस और नो? किसी एक से ये बन सकता है। इट मींस अवर प्रॉब्लम हैज बीन सॉल्व्ड। ओके, इट मींस इंटरसेक्शन नहीं भी बना, इन दोनों के लीनियर कॉम्बिनेशन से कोई ना कोई एक बन जाएगा। इट मींस इंटरसेक्शन में या तो 1 डायमेंशन आएगी या 0 आएगी। 0 आ नहीं सकती अब। यस और नो? इज इट क्लियर? नाउ द प्रॉब्लम इज 100% क्लियर।
Yes sir, yes sir।
यस।
Nullity can generate the range of this na, or we can say vice versa।
नाउ यू कैन गो एंड चेक अरिहंत। मुझे हंसी आ रही है। अरिहंत पब्लिकेशन की जो बुक है सॉल्यूशन PYQs, उसने सॉल्यूशन में डायरेक्ट लिख दिया डायमेंशन ऑफ W1 + W2 = 2। नाउ इट इज 2। आई अंडरस्टैंड, because if linearly dependent, these two are independent, so you have to eliminate this one. This will become the 0 by Roegelen transformations. But how you have written this is 2, how the student will understand? There is no explanation. There is no explanation कि how the answer is 2. Okay, चलिए कोई बात नहीं, डन। चलिए भाई, एक छोटी सी गलती सजा बन जाएगी, ध्यान रखना। Any other problem you are facing? Any other problem? And
One last question I have sir।
yes, you can ask.
T is R³ to R³ linear transformation।
A
T is a linear transformation, and its standard bases are given E1 E2 E3 as, and its matrix multiplication is 0 0 1,
matrix representation.
yes 0 0 1, 0 1 0 and 1 0 0, and then it is giving 4 options. Number one is no sir, no, different actually. Then T maps the subspace spanned by E1 and E2 into itself. Spanned by E1 and E2 into itself.
Your name?
My name Chet Narayan sir।
तुम्हारी ये प्रॉब्लम क्यों आती है? मतलब is page generated by this. This is this.
And
बताओ.
another is has distinct eigenvalues and has eigenvectors that span R cube.
मेरे से पूरी क्लास नहीं करेंगे.
And last is has a non-zero null space.
अच्छा ये बताओ भाई, सब लोग बताओ, मैं नहीं बता रहा, इतना आसान क्वेश्चन है. दिस इज वेरी इजी क्वेश्चन. मैं सोचा कोई टफ सा क्वेश्चन दे रहा है मुझे. यस, बताइए, पहले वाले में गलती हो गई थी. यस, कौन बताएगा इसका आंसर? व्हाट इज द आंसर? सी, सबसे पहली बात मैं आपको बता दूं, दिस काइंड ऑफ प्रॉब्लम समबडी इज आस्किंग, दिस इज ऑर्थोगोनल मैट्रिक्स. पता है आपको? दिस इज ऑर्थोगोनल मैट्रिक्स. देखो, अगर हमारे पास लाइक आई होता है, आई का इस टाइप से होता है, अपोजिट डायगोनल, दिस इज ऑलवेज ऑर्थोगोनल. यस और नो? दिस इज आइडेम्पोटेंट आल्सो. मैं वैसे ही कुछ क्वेश्चन डिस्कस कर रहा हूं इन दिस प्रॉब्लम. इज इट ऑर्थोगोनल? यस और नो? प्लीज चेक. व्हाट इज ए स्क्वायर? ए स्क्वायर आई, यस और नो? यस और नो? कितना टाइम लगाओगे? दिस इज वेरी स्टैंडर्ड प्रॉब्लम. सी, this is very standard problem. If you take any problem, so 1 0 0 0 1 0 and so on 1 0 0 0, this is very standard problem. This is orthogonal matrix, and orthogonal matrix has determinant, या तो इसका +1 होगा या -1 होगा. ओके, वैसे पता ही है आपको, this kind of problems has either +1 or -1. so basically you will rotate, ऐसे exchange कर दोगे, यानी exchange, you will not exchange this, you will exchange this one, not this one, you will exchange this one. So this determinant is -1 na, this you will multiply by this. Okay, determinant is -1. मैं आपको प्रॉब्लम समझा रहा हूँ पहले आपको बहुत सारी. यस, अच्छा, A transpose I and A transpose is A, सॉरी, ये इनवॉल्यूंटरी भी है. यस, यू आर राइट, ये इनवॉल्यूंटरी भी है. ए ट्रांसपोज ए भी आई है और ए भी आई है, तो ये ऑर्थोगोनल एज वेल एज इनवॉल्यूंटरी. इज इट राइट? दिस इज वेरी गुड, वेरी गुड. सो दिस इज इन्वर्टिबल. व्हेन द मैट्रिक्स इज इन्वर्टिबल, देन 1 1 on 2. इन्वर्टिबल मैट्रिक्स मतलब इन्वर्टिबल लीनियर ट्रांसमिशन 1 1 on 2. इन्वर्टिबल मतलब बोथ, आइदर मैट्रिक्स इज, सी, किसी ने मेरे से कल क्वेश्चन पूछा था, सर मैट्रिक्स 1 1 on 2 हाउ टू से. सी, when you have a problem like a linear transmission of r cube to r cube, this will represented by a matrix. You know, matrix is sorry, linear transmission is 1 1. What is the meaning? The null space contain only 0 element. Null space contain 0 element matlab null space of ax equal to 0 contain 1 element. Null space only 1 element matlab this is invertible matrix. Yes or no? Yes or no? Null space of ax equal to 0 contain only 0 element, it means this is invertible. So you can say in the case of matrices, a matrix is 1 1 on 2. Though matrix is 1 1, then on 2 always, because 1 1 means invertible. Here 1 1 r cube to r cube, there is a huge difference between the linear transmission and the matrix. Matrix is formed when the left hand side dimension, right hand side dimension same and finite. So if linear transmission you are saying 1 1 and both the side dimension are same, it means you are creating a square matrix. You are creating a square matrix. If linear transmission is 1 1 on 2, then matrix is invertible. Okay, so here matrix is invertible. This linear transmission 1 1 on 2, linear transmission 1 1, null space contain only 0 element. एक प्रॉब्लम तो मेरी यही सोच हो गई, हैज ए नॉन जीरो नल स्पेस. गलत. इन्वर्टिबल मैट्रिक्स हैज ओनली 0 null space. Yes or no? This is very simple. Number 1. कैसा कहते हो? has distinct eigenvalues, has distinct eigenvalues. See, बड़ा ही अजीब सी चीज है. When you study a square is equal to I, see, when you have find out the a square is I, can you find out a cube? What is a cube? A cube is a. Yes or no? A square is I, then a cube is a. Yes or no? I am not going to find out the characteristic polynomial directly. I am saying a square is I, then a cube is a, and a cube is, this is called the annihilating polynomial. Annihilating polynomial of degree 3 is unique. Yes or no? It means this is a characteristic equation. So lambda square minus lambda is equal to 0, lambda is equal to 0, lambda is equal to plus minus 1. So lambda is equal to 0 plus minus 1. It means all eigenvalues are distinct. लैम्डा जीरो कैसे आ गया? एक मिनट, इन्वर्टिबल लैम्डा जीरो कैसे? कुछ गलती कर दी क्या? कुछ गलती कर दी क्या? इनवॉलंटरी तो नहीं है इसका मतलब ये. सॉरी सॉरी, तुमने बेटा इनवॉलंटरी गलत बता दिया मुझे. नो, लैम्डा जीरो कैसे हो जाएगा? इनवॉलंटरी जीरो तो डिटरमिनेंट जीरो हो जाएगा. यस, कुछ गलती बता दी. ए क्यूब ए कैसे हो जाएगा? यस, होगा ही नहीं. हाँ भाई, ये बताना मुझे ना, व्हाट इज ए स्क्वायर? ए स्क्वायर देखना क्या आएगा, ए क्यूब बताना. कुछ गलती हुई.
ए स्क्वायर आई आ रहा है शायद.
पक्का एक बार चेक करो. अच्छा, ये ऑर्थोगोनल है क्या नहीं है, ये चेक करा?
चेक करता हूँ सर, वो अभी मैं.
एक बार चेक करो जरा. देखो हमारा तो आंसर गलत हो जाएगा. इन्वर्टिबल मैट्रिक्स सर, आइगन वैल्यू जीरो आ ही नहीं सकती. चेक करो. भाई अदर स्टूडेंट आल्सो जस्ट साइलेंट. प्लीज डू सॉल्व द क्वेश्चंस. You can think this is a IIT paper also. Okay. Eigenvalue, what are the eigenvalue? A square is I. नहीं, एक चीज गलती है इसमें. ए स्क्वायर इज आई, मिनिमल नीचे डाला. यस, वेट. यस, if matrix is not given, then you can write down like this: a square is I, then a cube is a. This may or may not characteristic, because if this is a like this is a, if you say this is the problem which is annihilating polynomial, if you annihilating polynomial you multiply anything. Okay, if somebody say for all matrix, then this is true for all matrix. Yes or no? See, if this is a problem which is annihilate, I have told you yesterday. No, this is not unique. Yes, I have told you yesterday, if this is annihilating polynomial like lambda square minus 1, if you multiply lambda minus 2, this is also annihilating. Lambda minus 3, this is also annihilating. So this is, all these are annihilating. Yes or no? So you cannot find out the characteristic equation from here, but you can tell कि this is the lambda square minus 1 is the annihilating polynomial. So lambda is equal to plus minus 1 is an eigenvalue. This is okay. Lambda is equal to plus minus 1 is eigenvalue. So lambda is equal to plus minus 1 is eigenvalue. So alpha, beta, like alpha is plus 1 and this is minus 1, you can say, and determinant is minus 1. So you can find other eigenvalue also by the help of this. ठीक है? But annihilating polynomial से अगर हम multiply करके निकालते हैं, then we can have infinitely many polynomial which is of degree of characteristic polynomial. We cannot find from here. If it is given here directly for all matrix, then we can say. Okay, so हमें वैसे ही निकालना पड़ेगा. Yes, ठीक है. इस प्रॉब्लम से हमें नई प्रॉब्लम बनी है हमारी कि इसकी हैज डिस्टिंक्ट आइगन वैल्यूज. डायरेक्टली हम नहीं कहेंगे, आपको यहाँ से निकाल लो आइगन वैल्यूज, देन यू विल फाइंड आउट व्हाट इज द आइगन वैल्यूज. ओके, देन इट इज क्लियर. सो निकाल, बताना इसकी आइगन वैल्यूज क्या क्या होंगी. कैन यू टेल मी व्हाट इज द आइगन वैल्यूज? क्या इसकी डिस्टिंक्ट आइगन वैल्यूज आ रही हैं? 1 1 और -1। ओके, तो डिस्टिंक्ट आइगन वैल्यूज नहीं है अगर आप कहते हो। सो हैज आइगन वेक्टर दैट स्पैन आर क्यूब। ओके, हैज आइगन वेक्टर दैट स्पैन आर क्यूब। ओके, हैज आइगन वेक्टर दैट स्पैन आर क्यूब। आर क्यूब को आइगन वेक्टर स्पैन कर सकता है। स्पैन जब करेगा अगर वो मैट्रिक्स डायगोनलाइजेबल होगी। यस और नो? जब वो मैट्रिक्स डायगोनलाइजेबल होगी। इज इट मैट्रिक्स इज डायगोनलाइजेबल? दिस मैट्रिक्स डायगोनलाइजेबल। देखो डिस्टिंक्ट आइगन वैल्यूज आती। इफ डिस्टिंक्ट आइगन वैल्यू डायगोनलाइजेबल, सो प्लीज फाइंड आउट द नल स्पेस ऑफ 1 and -1। सॉरी नल स्पेस नहीं, दैट इज आइगन स्पेस ऑफ 1 and -1। इफ डायमेंशन ऑफ आइगन स्पेस ज्योमेट्रिक मल्टीप्लिसिटी ऑफ 1 and -1 को ऐड करेंगे 3 आ गया, इट मींस दैट इज करेक्ट। am I clear? So what is the eigen space 0 0 1 0 0 0 1 0 1 0 0 1 0 0। ओके, इसका हमें 1 के करस्पॉन्डिंग निकालना है, तो -1 करेंगे। सो -1 इज -1 0 -1 निकालना। इसका आइगन स्पेस क्या आएगा? निकालने के लिए n minus r, n is 3। what is the rank of this matrix? The rank of this matrix is 1 -1 0। I think what is the rank of this matrix? Rank of this matrix is 1 na, so answer is 2। okay, and what is like 0 0 1 0 1 0 and 1 0 0 corresponding to -1? -1 is this is -1 0 0 -1 1 1 or 0 -1 0 minus -1 my 1 minus -1। okay, 1 minus -1 that is 2। yes or no? This is what is n minus r? N minus r is 3 minus r। what is the rank of this matrix? This is I think 2, that is 1। so sum is 3। it means linear independent eigenvector has this matrix is diagonalizable। yes or no? This matrix is diagonalizable। This matrix is diagonalizable। is it clear? yes or no? yes or no? This matrix is diagonalizable? yes। so going back, this matrix so invertible है तो 1 1 नहीं, 1 1 है, ये क्लियर हो गया। हैज आइगन वेक्टर, यस डायगोनलाइजेबल है, डायगोनलाइजर मैट्रिक्स है। टी मैप सबस्पेस ऑफ स्पेस स्पैन्ड बाय दिस इनटू इटसेल्फ। so basically the meaning of this subspace is you can see E1 E2 से generated subspace। so TE1 TE2 whatever subspace you will have, the same subspace will be generated by right hand side। okay, so you can find out TE1 TE2। see, you have this 0 0 1 0 1 0 or 1 0 0 TE1। this is called T, this is E1। what is this? if you multiply this, this is 0। if you multiply this, this is 0। this is 0। ठीक, TE2 simple 0 1 0। so what is this? E1 E2 subspace generated by E1 E2 and T1 T2 are same, yes or no? because whatever basis you are saying, same or not, just check। E1 E2 what is E1 E2? that is 1 0 0 0 1 0 and this is 0 0 1 0 0 1 and 0 1 0। both subspace are same, yes or no? see, going back, T maps subspace spanned by this into that subspace। see, subspace are same or not? tell me। subspace are same or not? Tell me. Now there are two questions. One is called subspace. One is called dimension of subspace. समझे? See, subspace. आज आप बोल नहीं रहे हो, क्या बात हो गई? Subspace is like x plus y comma linear combination of this, na? So x comma y comma sorry x comma y comma 0 such that x y real number. This subspace is 0 comma y comma z such that y comma z belongs to real number. So both subspace are different. These subspace are not same but has same dimension. But has same dimension. मतलब because R cube has infinitely many subspace of same dimension. Okay. So sorry, not infinitely many. Sorry, infinitely many subspace. But same dimension. These two has same dimension too. This has two dimension, but subspace are not same. Is it clear? कि subspace are not same. Am I clear?
Yes sir.
Yes
sir. वही बस ए ऑप्शन में ही दिक्कत थी, बाकी तो उससे तो पता चल रहा था.
Any other problem? So this is clear. And one problem is student were asking, sir, what is the dimension of matrix? See, dimension of matrix we cannot find. Basically, whenever somebody is asking dimension of matrix, dimension of a range space of a matrix, yeah, dimension of a null space of a matrix. This kind of question, I think you have understood the problem. Dimension of range space, a dimension of null space of a matrix. Is it clear? चलिए done. Next problem is, अच्छा किसी और की प्रॉब्लम नहीं है कुछ भी, इसकी जो प्रॉब्लम है पूछ सकता है. Next is, what is the range of a matrix? Range is also clear. Range मतलब somebody is asking range मतलब that is a range space, or rank मतलब dimension of a range space. One is dual space. One problem is dual space. See, dual space का कोई क्वेश्चन एग्जाम में नहीं आएगा, but I am saying you have a linear transmission from a vector space U to V. U is a vector space, V is a vector space over the same field. U is a vector space over the same field. U and V are vector space over the same field. Then how many linear transmission you can have? See, if you have T1 is linear transmission, T2 is also linear transmission, because from some vector space to some vector space you have so many linear transmissions. So if these two are linear transmission, then addition of these two are also linear transmission. Yes or no? Can I say like this? Because this is a linear transmission, this is linear transmission. Addition is also linear transmission. You ले सकते हो A alpha plus B beta of T1 plus T2 is nothing but, कैसे define करोगे? T1 of A alpha plus B beta plus T2 of A alpha plus B beta. And then finally, this is linear transmission. You can write down A of T1 plus T2 plus A alpha plus B of T1 plus T2 of beta. You can do these things. We have discussed already. So T1, T2 linear transmission, A of T is also linear transmission. That is A of T alpha. Okay. It means this, if you have two linear transmission, then you can say we have the sum and the scalar multiplication is also linear transmission. So you can prove the set of all possible linear transmission, set of all possible linear transmission from UF to VF is a vector space. Under the operation, linear transformation additions, linear transformation scalar multiplication, and this is called dual space. This is called dual space, and dual space is known as home UV. Home UV means basically linear transformation is called as homomorphism between two vector space. Basically, first of all, we have studied group theory homomorphism we have discussed, then isomorphism we have discussed, group theory homomorphism, then one more on to the isomorphism. Then we move to the vector space, sorry, ring theory isomorphism, ring theory isomorphism you have done. Okay, this ideal isomorphism. Okay, all these things in the ring theory. We move to the vector space. Two vector space are isomorphic, that is different thing. But now we are saying linear transformation. Linear transformation कुछ नहीं है. Homomorphism between two vector space, as group as vector space. So group theory, group homomorphism, vector space homomorphism. When you say vector space homomorphism, the new name is linear transformations. So vector space homomorphism is called the linear transformation. So it means the set of all linear transformation from a home UV or U to V is called the home UV. And if agar iski dimension, like a dimension of a vector space U and V are finite, then home UV, the dimension of home UV is equal to dimension of U into dimension of V. If both dimension are finite dimension, both space are finite dimension vector space. और बताइए इसके अंदर प्रॉब्लम क्या है आपको linear transformation home UV में बताइए. Yes. Do you have any problem in this problem? Yes. What is the problem in this problem? No problem. Yes. Done. Student who has asked this problem, whosoever has asked, please tell me if you have any problem, because this is clear. If you have any problem, you can discuss. Yes. Done. Next. ये आप लोगों को इंटरेस्ट नहीं आ रहा लीनियर ट्रांसफॉर्मेशन में. These are the good problem. चलिए ब्लॉक मैट्रिक्स एंड देयर प्रॉपर्टीज. यस, ब्लॉक मैट्रिक्स पे डिस्कस करेंगे. यस. सो बिफोर दैट, W1 plus direct sum of W2. W1 direct block matrix we will discuss tomorrow, because I will give you some problems on the block matrix. Then it is very easy to understand. Okay. Yes. Don't worry. W1 direct sum. This. What is the meaning of this direct sum? This is not written in syllabus, but sometimes somebody is asked this question, then you can write down. You know W1 plus W2. What is W1 plus W2? This is a subspace. This is a subspace of V. This is subspace of V, where W1 is subspace of V and W2 is also subspace of V. W1 plus W2 is equal to W1, मत लिखो, alpha 1 लिख लेते हैं. This is alpha 1 plus alpha 2, such that W1 alpha 2 belongs to W2, and we have proved that this is a subspace, and this subspace is generated by W1 union W2. But what is W1 plus W1 direct sum W2? W1 direct sum is called W1 plus W2 with intersection of this subspace is only 0. This is called direct sum. Okay, this is called sum of two subspace, any subspace, but this is called direct sum. It means these two are distinct subspace. These two are distinct subspace. Disjoint मतलब होता है intersection is 5, but subspace cannot have intersection 5. Okay, this is called disjoint, not disjoint, distinct subspace. So W1 plus W2 is equal to, okay, W1 direct sum is plus W2 is equal to this one, but W1 intersection W2 is equal to 0. Can you give me an example of a W1 plus W2, W1 W2 such that These are disjoint, sorry, distinct subspace. Yes, we have set of all matrices, है ना? Set of all matrices MNR. MNR is a vector space. Is a vector space. And W1 is the set of all symmetric matrices. W2 is all these matrices from MNR. A transpose is minus a symmetric square matrix. So any matrix MNR can be written as a W1 direct sum of W2. Yes or no? Because if matrix is symmetric, cannot be skew symmetric. Only 0 is the matrix which is symmetric as well as skew symmetric. 0 is only the matrix which is symmetric as well as skew symmetric. Yes or no? And any matrix can be written as a sum of symmetric and skew symmetric. Yes or no? क्यों? किसी भी मैट्रिक्स को आप ऐसे लिख सकते हो A is equal to A plus A transpose by 2 plus of A minus A transpose by 2. This is symmetric, this is symmetric. Okay, so it means if MNR is the set of all matrices, which is a vector space, which is written as a direct sum of two subspaces. One subspace is set of all symmetric matrix, and second is set of all skew symmetric matrix. This is also clear. Yes. One more example you can take. मेरे पास मैंने लिया है like vector space V is equal to R square and W1 is only the x axis पे जितने भी points आएंगे. This is a subspace and W2 is also 0, y. Says that like done. So V is equal to W1 direct sum of W2. Why? Because we have these two axes, x axis, y axis. This is x axis, this is y axis. Okay, this is x axis, this is y axis. What is the intersection? What is the intersection? Only 0. Okay, but any element can be written as this plus this, है ना? This plus this, any element of R square can be written as this. Okay, so you can write down these things. Is it clear? Yes or no? Done. Yes. One more question you can see. F is R to R be a function and V is a vector space set of all function from R to R. F is a function. Okay, done. Then V can be written as a W1 plus W2, where W1 is set of even function plus odd function. See, odd function means f of minus x is equal to fx. F of minus x is equal to minus x. किसी भी फंक्शन को आप लिख सकते हो f plus f of minus x by 2 plus f plus f of, जैसे even odd वाला ना, एक बार चेक करना this is okay or not. F of minus x. This is even or odd? Yes or no? देखना, this is even, x को minus x रखने पर that is even, x को minus x रखने पर that is x minus x. Yes, that is odd function. You can check this example. I think you have never studied this kind of examples. Please study and do solve this problem. And this is even or odd function. This is and dual function is which is always even and odd both. So we can say this is the direct sum. So I hope you have understood all these problems. So only block matrix is okay. Block matrix मैंने नहीं समझाई है. Block matrix की मुझे कुछ problems आपको देनी है ना? That's why I have not discussed this block matrix. So do you have any other problem which you want to discuss? Any topic in the linear algebra? Otherwise tomorrow onwards we will discuss some problems. Yes. बताइए. Pranshu, yes, you can speak.
हेलो सर.
Yes.
सर हमें ऐसे टाइप का क्वेश्चन मिल सकता है जैसे टू वो दे रखे हैं बेसिस r² टू r³, तो हमें ये करना है कि r³ के जो बेसिस है उसको r² के बेसिस में ट्रांसफॉर्म करना है, ऐसे कुछ क्वेश्चंस।
You have given a basis r square and r cube.
ऑर्डर स्टैंडर्ड है वो
हम्म।
दे दिए, जैसे 1x और x², और एक बेसिस दे दिया है, कुछ इक्वेशन बना के दे दिया है 2x² प्लस
हाँ,
x।
what is the problem? Yes, no problem. 1x x square. दूसरी बेसिस दे दी है इसने, like 1 plus x plus, like this.
यस सर।
What is
अब
the
हम व्हाट सर?
what is the transposition you are asking? What is the linear transposition which map this to this? ऐसा कुछ?
यस सर।
Okay. So I understood your problem. I will give you problem tomorrow. Okay.
ओके सर, और मैं भी आपको भेजूंगा सर
No
क्वेश्चन
problem.
पीडीएफ
See,
में।
I have understood what you are asking. You are asking कि there is a linear transformation is given. I think question भेज दोगे तो और क्लियर हो जाएगा, जैसे मुझे समझ में आ रहा है कि ये linear transformation is given and you are asking कि linear transformation from like r cube to r cube is given and there is a ordered basis of this linear transformation, ordered matrix from this to this and this to this. So how to transform this to this by some matrix P? This is
यस यस सर।
ये कह रहे हो ना?
यस सर। सर वो फीड वर्क कर रहा था कल, जब पकड़ में आई सर ये क्वेश्चन।
तो मेरे पास क्वेश्चन तो है, एक मिनट, क्वेश्चन हर क्वेश्चन तो मुझे याद नहीं है ना, I know the
यस सर।
theory, but I have to take one question from the book. रीड पर में ही है क्वेश्चन, वेट ऐसे कुछ होगा, मेरे पास मैंने लिख रखा है। Once I give you question, it will be very clear. Is there any question? You want question respect order, which is this fundamental. अच्छा, पहले तो हम एक क्वेश्चन ये करते हैं। Your question was, अच्छा एक चीज तो है, but right now you had a difficulty. You had difficulty in like previous class when we have started some topic 4-5 days. Right now it is okay. Right now whatever topic I have taught, the topic is clear. अगर हम आज के समय में देखें, because we are going to the IIT exam, right now any problem? Right now you are feeling कि linear algebra, integral calculus and group theory, you can do so many problems in the integral calculus, real analysis, linear algebra, all these things you can do easily. मतलब you have a confidence of like that, है ना? So सबसे बड़ी बात ये है, जो हो गया ठीक है, अंत भला तो सब भला है। तो हमारा फाइनल जो हमारा है, अब आने के बाद तुम्हारी सारी चीज क्लियर है। उस समय तुम इतने ज्यादा परिपक्व नहीं थे, परिपक्व मतलब इतने ज्यादा मैच्योर नहीं थे लीनियर अलजेब्रा में। नाउ यू कैन अंडरस्टैंड ईच एंड एवरीथिंग वट एवर आई एम सेइंग, सो आई वांट दिस वन, नो प्रॉब्लम, डन। क्वेश्चन इज फर्स्ट ऑफ ऑल फाइंड द मैट्रिक्स ऑफ linear transformation on R3 to R3 defined by TABC is equal to 2B plus C, A minus 4B and 3A with respect to ordered basis B 0 1 0 0 0 and B dash this one. First of all, you have given a linear transformation, and in this linear transformation, you have to you have two bases, and we have to find out the matrix with respect to this ordered basis. Can you find out? Yes, can you find out the matrix? Please tell me. Find out. Then I will give you the problem which you are asking. How did you find out? See, left hand side is called B. Okay. So T of 1 0 0. What is this? That is 0 1 3. Yes or no? And this you have to write down the linear combination of B dash. Do you know this one? You have to write down this as a linear combination of B dash. Yes or no? Like A of 1 1 1, B of 1 1 0, and C of 1 0 0. Have you write down like this? Have you find out this one? Like T matrix with respect to B and B dash is it will be like this. Yes. Yes. And T of 0 1 0 is mapping to 0 1 0 0 1 0 0 1 0. यहाँ पे भी लिखोगे आप like this. You have to find out. I don't know what is the answer. Please tell me what is the answer. This is 0 0 1 0 0 0 0 1 0 0. We'll find out this one. You can write down A1 B1 C1 A2 B2 C2 A3 B3 C3. Yes. What is the A1 A2 A3 B1 B2 B3 C1 C2 C3? Yes. Tell me फटाफट बताइए so that we can solve the problem. Yes. This is a new problem, and I will give you more problem here. But first of all, find out the answer. Is it this one? 0 1 3. Pransu, is it right? मैंने आंसर निकाला, आप निकाल लीजिए. आपने क्या आंसर निकाला है? क्या ये आंसर मैच कर रहा है? ऐसे निकाला है? मुझे नहीं पता है. 2 - 4 0. 2 कैसा जाएगा? अच्छा यार, चलो ठीक है, देख लेते हैं. प्लीज चेक 2 - 4 0. Third is 1 0 0. Yes, please student, please verify this one. Is it correct or not? Please verify. No, please find out the correct answer. Yes. A1 A1 B1 C1 A2 B2 C2 and A3 B3 C3. फटाफट निकाल. What is the answer? Student 300. भाई 300 तो आ ही नहीं सकता मनोज. ये 3 आएगा. कैसा जाएगा 013 को 3 कैसे लिख दोगे? है? How did you find out this answer? Can you find out? Can you compare this and find out the answer? A1 is 0. Absolutely. A1 is 0. Any other student? Are you getting my point? What I'm trying to say? अच्छा मैट्रिक्स आपको पता है ये जो A1 B1 C1 होता है इसे हम ऐसे लिखते हैं कॉलम वाइज. यू नो दिस थिंग? हाँ 0 0 3 1 1 -1. मुझे ये समझ में नहीं आ रहा. आपने लिख दिया 1 1 -1 तो 1 लिखा तो 1 1 2 -1 तो 1 आएगा. यहाँ पर गलत हो गया ये तो. मुझे ये नहीं समझ में आ रहा आप कर क्या रहे हो. That is 0 0 3 which can be written as 0 1 3. एक पॉइंट मैं निकाल देता हूँ फिर आप निकाल लेना. B1 ये क्या है 1 1 0. वन जीरो जीरो. ठीक ना. So A1 plus B1 plus C1 is 0. So A1 की वैल्यू 3 आ गई तो B1 की वैल्यू क्या आ गई? A1 plus B1 plus C1 0. A1 plus B1 is equal to 1 है. A1 की वैल्यू 3 आ गई और B1 की वैल्यू क्या आ गई? C1 क्या आ गई? ये आ गई ना 3 - 2 1. ऐसे लिखोगे ना. So this is wrong. Yes. So have you done before this kind of problem? Yes. Have you done last? Yes. Last is 001. Where? This one? This one? चलिए जो भी है मुझे नहीं पता. अच्छा कोई पूछने लगे T with B to B, if somebody is asking T with B to B, बेसिस टू बेसिस निकाल लो, ठीक है, यही क्वेश्चन पूछ रहा था वो जिसने पूछा था अभी। बेसिकली मेरे पास जो भी प्रॉब्लम थी, द प्रॉब्लम इज T is a mapping, okay, T is a mapping, so T you are asking B, मेरे पास क्वेश्चन तो मेरे पास ये हो गया, मेरा क्वेश्चन इज कंप्लीट, माय क्वेश्चन इज कंप्लीट, T from B to B dash, okay, but somebody is saying T B to B, जनरली हम क्या निकालते हैं, T B to B, and generally if there is some basis is not given, the B dash to B dash, T B dash to B dash, you have some matrix, ठीक है, 3 by 3, the question is कि you have T B to B dash, T B to B and T B to B dash to B dash, what is the relation between these three matrices, what is the relation between these three matrices? सी मैं इसे और अभी कल करा दूंगा, टाइमिंग आपके पास नहीं है। These matrices are similar. See, this matrix is similar to this and this is similar to this. Okay, why similar? Because similar matrix has, बिल्कुल basically आप किसी भी basis से निकाल लो, if you take any basis you will have a matrix and that matrix has say eigen value. If matrix is not similar, then you can say कि matrix is not similar, then eigen value will not be same. But we don't know na कि which basis you are taking. You can take any basis, yes or no, you can take any basis, there is no guarantee, it is not written that you will take only standard basis, you will find the matrix and you will find the eigen value. You can take any basis, you will find the matrix. A matrix has the same eigen value. Basically this concept is designed by the similar matrix, so I will tell you how these matrices are similar and what are the transformation there, so that from this matrix you can get that this matrix, from this matrix you can get this matrix, from this matrix you can get this matrix. So there is some transformations, okay, that is called P inverse AP वाला transformation होता है, P inverse AP. How to find that P inverse? So that let us consider these two are similar, then you have to find out the P, yes or no. If you say P, then you can say, oh, from this two you will get this, from this you will get this. So that is called the transition matrix, the concept of transition matrix. Yes, Pransu, you can speak.
हेलो सर
Yes.
जी, हेलो
Yes.
जी सर, मैंने ऐसे किया था सर, जो आपने ये टी टू बी मतलब बी टू बी डैश निकाला है ना, उसको ऐसे किया था, आप लिखोगे जरा
Yes.
नेक्स्ट पेज। मैंने लिखा था रो वाइज लिखेंगे, जैसे 0 2 1 1 -4 0 3 0 0 is equals to A1 B1 C1 A2 B2 C2 and A3 B3 C3।
नहीं गलत है ना, ये कॉलम वाइज डालते हैं
इनटू, सर लिखो तो सही, इनटू इसी में इनटू अभी A1 के बाद में 1 1 1 1 1 1 0 एंड 1 0 0। अब मैंने इसको इसका इनवर्स निकाल के A1 A2 और
बट जो भी आपने करा मैं समझ गया, बट उसके पीछे का लॉजिक तो होगा।
यस सर।
So I will give you logic ki how to find out the matrix, that is called transition matrix. Have you ever studied transition matrix? कभी पढ़ा है transition matrix कुछ होती है?
नो सर।
नहीं सुना ना? That is called P matrix. P is called, वो होती है ना, like basically you have A matrix, you have B matrix. A is designed by B and this is called B dash. Yes or no?
यस सर। एक ही आइगन वैल्यू निकाल के आइगन वेक्टर निकालते हैं, वो उसका बेसिस।
नहीं मैं बताऊंगा कल बताऊंगा, डोंट वरी। कल हम इसका ब्लॉक मैट्रिक्स और ये ट्रांजिशन मैट्रिक्स क्लियर कर देंगे। और आप जरा ध्यान से देखोगे ना, आप जरा इस मैट्रिक्स की ये कहां गई, बी डैश से मल्टीप्लाई करना, इसमें देखना ये तो नहीं आ रही, क्या यही ट्रांजिशन मैट्रिक्स है? वी विल डिस्कस टुमारो व्हाट इज द ट्रांजिशन मैट्रिक्स। ठीक है,
ओके सर।
P इनवर्स AP इज इक्वल टू दिस। वी विल देखो अभी मैंने एक बेस बना दिया है, आपको पता लग गया हाउ टू फाइंड बी टी बी बी डैश टी बी बी टी बी डैश बी डैश। अब इन तीनों के बीच में रिलेशन क्या है वो डिस्कस कल करेंगे। ये मैट्रिक्स सिमिलर मैट्रिक्स का कंसेप्ट है, एक बार आप किसी भी बुक से फ्रीड बुक से एक बार देखिए क्या कहीं ट्रांजिशन मैट्रिक्स या सिमिलर मैट्रिक्स कंसेप्ट लिखा हुआ है इसमें। यस, वी विल डिस्कस टुमारो। डन।
ओके सर।
ओके स्टूडेंट, सो थैंक यू वेरी मच स्टूडेंट।